All right, we're going to go ahead and talk about the fundamental theorem of algebra. Fundamental theorem of algebra, kind of summarized and put it into my words here. Every polynomial with a degree greater than or equal to 1 will have at least one solution, and that solution could be real or imaginary. And then another piece to that, an nth degree polynomial will have exactly n solutions, and those solutions could include repeated solutions, and they could be real or imaginary. So kind of putting that into practice, what that does is it helps us to understand that when we get a polynomial function, we should be able to find one solution, whether it be real or imaginary. So when we're trying to solve, and we use kind of all the tools we have to solve these, whether it be factoring or polynomial long division or synthetic division to help out, or completing the square, or form factoring, or quadratic form, or just the many different things you've learned to solve. So we're going to try some of those here. So find the number of solutions or zeros, and then we're going to have, solve. Okay, how many solutions does this have? Well, if we look at the leading coefficient, okay, and think back to our fundamental theorem here, an nth degree will have exactly n solutions. Well, that means if I'm looking at this, this is a third degree, meaning it will have 3 solutions. Now those solutions could be real or imaginary, and they could include repeated solutions. Okay, how many zeros will this function have? Well, it's a 4th degree, therefore it could have 4 solutions. So what I'm going to do now is we're going to actually solve. Okay, so this first one right here, it's a cubic. I can't factor anything out, so I'm going to go ahead and do some synthetic division. And if you recall from previous lessons, you really want to try the factors of 3 first, and the first factor I always try is 1, and I always test 1 by just looking at the coefficients. This is 1x cubed plus 1x squared minus 5 plus 3. I just add my coefficients, and if that equals 0, that means 1 goes into it. So 1 plus 1 plus negative 5 plus 3, that's actually 0, meaning 1 goes in to this polynomial evenly. So now I'm going to use synthetic division to figure out how many times 1 goes into it. So I've got my 1. I'm going to divide by, I'm going to have 1, 1, negative 5, and 3. Okay, bring down that 1. 1 times 1 is 1. Add those. 1 plus 1 is 2. 1 times 2 is 2. Negative 5 and 2 is negative 3. And 1 times negative 3 is 0, or not 0, is negative 3. And 3 and negative 3 is 0. Okay, so I tried that 1. That 1 represents the binomial x minus 1. Okay, that would give me the solution of 1 there, if I were to set it equal to 0. And so now I have a quadratic. So I know that 0 is equal to x minus 1 times this quadratic, which is 1x squared plus 2x minus 3. And the benefit of getting its quadratic, now you can factor or use quadratic formula or completing the square, any of those tools we have to solve quadratics. So in this case, it factors evenly. X squared plus 2x minus 3 becomes x plus 3 times x minus 1. Hopefully that's fairly fast for you now. Meaning that the solutions here, I set this part equal to 0 and solve. So x minus 1 equals 0, so x is equal to 1. X plus 3 equals 0, therefore x equals negative 3. And x minus 1 equals 0, and once again, we know that from just over here, x equals 1. So my solutions, my 3 solutions, are 1, 1, and negative 3. Now when we list them, we don't have to list 1 twice. Okay, we can list it once. So really, we could just say, well, I'm going to put my negative 3 and then positive 1. Unless it asks for the repeated solutions. There we got it. Okay, but note there are 3. That one, and that one. It's just the 1 appears twice. All right, how many zeros does this one have? Well, we know it has 4 possible solutions. Okay, to solve it, I'm going to once again check out synthetic division. So I'm going to look at this and I'm going to go, well, I'm going to try my 1. Okay, once again, add my coefficients, 5 and negative 7 plus 2. That actually equals 0, which means 1 goes into it. I'm going to switch up colors here. Okay, so 1 goes into it, and the number of times, well, let's see, that's 5, x to the 4. I need to put a place value of 0x cubes minus 7x squareds, and need to put another place value of 0x, and then 2. It's going to drop down that 5. 1 times 5 is 5. 0 and 5 is 0 plus 5 is 5. 1 times 5 is 5. Negative 7 and 5 is negative 2. 1 times negative 2, negative 2. 0 and negative 2 is negative 2. 1 times negative 2 is negative 2. 2 and negative 2 is 0. All right. So what that means is that this binomial with x is represented by x minus 1. X minus 1 goes into this. This is represented by 5x squared, or 5x cubed, excuse me, because there's x to the 4th, plus 5x squared minus 2x minus 2. That's what this line of numbers represents. Okay? And so what I want to do is, once again, probably use synthetic division. I'm going to test again to see if 1 goes into it. Well, 5 plus 5 is 10, negative 2 and negative 2 is negative 4. That gives me a remainder of 6, so 1 doesn't go into it. Now, if you ever want to test negative 1, the way you test negative 1 is if you look at these odd powers. The odd powers will actually change coefficients. So if I'm testing negative 1 to see if it goes into it, this positive 5x cubed would actually become negative 5. And this 5x squared would actually stay positive 5. This negative 2x would actually become positive 2. And that negative 2 would stay negative 2. And the reason that is because if I put negative 1 in here, negative 1 times negative 1 times negative 1 is negative 1 times 5 is negative 5. If I put negative 1 in here, negative 1 times negative 1 is 1 times 5 is positive 5. So the sign didn't change. Only when you have an odd power, so an odd power of 1. So if I put negative 1 in here, negative 1 times negative 2 is positive 2. It switched it. There's no x here, so we don't have to worry about it. It's actually x to the 0. So negative 5, positive 5, that's 0, and that's 0. So that means negative 1 goes into this whole thing. And negative 1 goes in. So what I'm going to do is I'm going to do synthetic division again here. Okay. I'm going to put a negative 1 on the outside here. Negative 1 goes in. We'll drop that 5 down. Negative 1 times 5 is negative 5. That's 0. Negative 1 times 0 is 0. That's negative 2. And negative 1 times negative 2 is positive 2. That gives me 0 right there. So this right here is representative of the binomial x plus 1. Okay? So we have x minus 1. We have x plus 1. And now we have this quadratic right here, which is 5x squared minus 2. And so if I'm kind of keeping with what I'm doing, I'll write it over here. 5x squared minus 2. Now, since it's a quadratic, I'm not going to worry about doing any more synthetic division. So what I have now is I have f of x is equal to x minus 1 times x plus 1 times 5x squared minus 2. Okay, and I'm going to set f of x equal to 0 because I want to find the solutions, meaning that if I have each of these quantities being multiplied together, one of those is going to be 0 because that's the only way to multiply to make 0. So if I set x minus 1 equal to 0, I get the solution of it. X equals 1, which we knew. We had that right here. If I set x plus 1 equal to 0, we get the solution of x equals negative 1, which once again, we knew. We had that right there. Okay. So those two solutions we already had. Okay, this one and this one, we had those both there and there. The one we didn't have was 5x squared minus 2 equaling 0. That means 5x squared equals 2. X squared is equal to 2/5. Now when I take the root of that, I'm going to have x is equal to the square root of 2 over 5. And when we impose a root, we've got to put that plus minus. Whoops. Okay? And so really that means I have root 2 over root 5, which is plus minus. And remember, we can't have a radical in the denominator. So we're going to multiply by root 5 over root 5. Okay, so switch that up here. We'll say we're going to multiply times root 5 over root 5, which is 1. So whatever is in the denominator, that root, just multiply by that over itself. And that's going to give me root 10. So root 2 times root 5 is root 10 over root 5, and root 5 is root 25, which is 5. And we have the plus minus. Okay, so my solutions now are that, and that, or 1, negative 1, and root 10 over, or plus minus root 10 over 5. So I'd write my solutions as x equals positive and negative 1 and positive and negative root 10 over 5. There we've got it. Okay. Let's go ahead and move on here. Try another one here. Finding the zeros of the polynomial function. Just want to point out one thing. Both of these solutions here were real numbers. 1 and negative 1 were real. This is a irrational real number. The 1 and negative 1 is a rational real number, as is negative 3 and 1. Notice the only thing we don't have is an imaginary solution yet, but we're about to get one. So let's go ahead and take a look at that. Let's look at this one. So find the zeros of the polynomial function. The first thing I'm going to do is I'm going to look at this, and I'm going to say, well, if I'm going to find the zeros, I'm going to set this part equal to 0. So I'm going to plug 0 in for f of x. Okay? And then from there, once again, I can't factor anything. I'm going to do synthetic division. And hopefully I'll quit switching the page. So I have 1, negative 2, 6, 1, and negative 6. Notice I'm missing a 0x to the 4th in there. Okay, but before I deal with that, I'm going to test out 1 and see if 1 works. And the way I test it, once again, is I just look at the coefficients. 1 plus negative 2, that's negative 1, plus 6 is 5, plus 1 is 6, and negative 6 is 0. That means 1 will go into this. Okay, so I'm going to go ahead and test out 1. I need to give myself a lot of room here, so I'm going to say 1 goes into it. Done that. I'm going to use my coefficients. I have 1x to the 5th, 0x to the 4th. So make sure you put that place value holder in there. Negative 2x cubed, positive 6x squared, positive 1x, and negative 6. Drop that down. We get 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 2 and plus 1 is negative 1. 1 times negative 1 is negative 1. 6 and negative 1 is 5. 1 times 5 is 5. 1 plus 5 is 6. 1 times 6 is 6. Negative 6 and 6 is 0. So this right here represents the binomial x minus 1. 1 goes into it. Okay. So the function that's represented by the solution, x times 1 times this thing, which is 1x to the 4th, plus 1x to the third minus 1x squared plus 5x plus 6. That whole thing times x minus 1 equals our polynomial, our original f of x. Now notice, I can't factor it. Nothing I could do. It's a fourth degree, so I'm going to keep trying to do synthetic division. And in this case, I'm going to look at and see if 1 goes into it again. Well, this is 1x to the fourth, 1x cubed, negative 1x squared, 5 and 6, or these coefficients. These added up, do they make 0? 1 plus 1 minus 1 plus 5? No, they don't. Okay, but we could also test negative 1. That when we are testing negative 1, what we're looking at is the odd powers. They change the coefficient. So when I put negative 1 in, the even power coefficient stays the same, but an odd power, the coefficient switches signs. So even power stays the same. Odd power to the first power switches signs. And the constant actually is x to the 0, which means even, it doesn't change. But 1 minus 1 is 0. That's negative 6 plus, yeah, that's 0. So that means negative 1 will go into this, okay? And the way we'd want to write that out, actually just draw another bar right there. We put negative 1 on the outside. And we'd bring down this 1. Negative 1 times 1 is negative 1. That's 0. There's 0. That's negative 1. That's 1. That's 6. That's negative 6. That's 0. All right. So this represents, right here, 1x cubed plus 0x squared minus x plus 6. That is that. Okay. This binomial right here is x plus 1. All right. Well, we're almost there. We have a trinomial now. We can't do anything with it. We could test 1, negative 1, and 6 is not 0. We could test negative 1, so let's switch up the colors. Negative 1's easy. This now is negative 1. This is still 0. This is positive 1. And that's 6. It does not make 0. So look at your back term. The other things, you're testing 1 and negative 1 because they both go into 6 in your constant. You could try 2, see if 2 goes into it. But notice that you have, if you put a 2 in, that's going to be that's going to be 8. This one isn't going to matter. That's going to be minus 2 plus 6. That's not going to work. Got too many positives. So you're going to probably have to try a negative number. So I'm going to try negative 2. Okay. Whoops, put it in the wrong spot. And I don't have a real quick method for negative 2 other than just plugging it in, which you could do if you don't want to just try it with synthetic division. You could just plug in negative 2 and crank out. You could say, well, that's going to be negative, negative, negative is negative 8. 0, negative, positive. Negative, negative 2 is positive 2. And then positive 6. Well, notice that gives me 0. It's going to work out. That's 1. Negative 2 times 1 is negative 2. Negative 2 times negative 2 is 4. Negative 2 times 3 is negative 6. 0. This represents x plus 2. And this represents 1x squared minus 2x plus 3. So we now have a quadratic. So we have our original function, factors to become 0 equals x minus 1 times x plus 1 times x plus 2 times x squared minus 2x plus 3. All right, so it's easy to solve these pieces. This piece right here is going to give us a solution of x equals 1. Okay, we knew that from right here. Okay. This part gives us a solution of x equals -1. This part gives us a solution of x equals -2. This part, we try to factor two things and multiply to make 3 and add to -2. Nothing does that. We could try using the quadratic formula or completing the square to solve it. So I think I'm going to do completing the square. Okay, so I'm going to take that quadratic and I'm going to say, well, x squared minus 2x plus 3. To complete the square, I'm going to set it equal to 0. The method I use, I take that and I bring the 3 over to the other side, and I leave a gap right here. This gap is to help me complete the square. Okay, I want to make a perfect square trinomial here, and the reason I chose to complete the square is because my b term is an even number, so it makes it easy to make my binomial. I just cut that number in half, so I have x minus 1 quantity squared. Okay, well, I cut this in half and square it, and that becomes my back number. Okay, so -1 squared is 1, and whatever I add here, I have to add here. Now, if you're not good with completing the square, what you might want to do is the quadratic formula. Okay, that would give you -2 on this side. Okay, then I'm going to take the square root of both sides. X minus 1 is equal to, when I impose a square root, I put plus minus root -2. I'm going to go ahead and add 1 over, so x is equal to 1 plus minus root -2. And I'm going to pull that negative out, so I'm going to get x is equal to 1 plus minus I root 2. And notice that means I have two solutions there. I actually have, this is the compact way, I have x equals 1 plus I root 2, and x equals 1 minus I root 2. Okay, now we usually write it like that. All right, so my final solution, I've got 5 of them. 1, 2, 3, 4, 5. It was a 5th degree. Final solution, x is equal to the set containing positive -1, -2, and 1 minus I root 2. Actually, 1 plus minus I root 2. Now, some people get really picky on the way you write this. They may want to see the -2 go first, and so if you have that, you put that. Some people want to see the 1 plus I root 2 first. Okay, I'm good with that. All right, got it. Okay, one other thing that's helpful is to understand the complex conjugates theorem. And this just says that if you have a complex pair of complex numbers in the form of a plus bi and a minus bi, when you have the a plus bi and a minus bi, it's a pair. They come together, they're called complex conjugates. And then notice we just had that. We had it down here. Okay, we had, here's our a plus bi, b being the root 2 and I, and a minus bi. Okay, whenever you have that, whenever you have one of them as a solution, the other one comes along with it. They're always together. Okay, they're a package deal. Okay, that's called the complex conjugates theorem. Okay, and really we can read the rest of this. If f is a polynomial function with real coefficients a plus bi is an imaginary 0 of f, then a minus bi also has to be a 0 of f. Okay, so in other words, let's try one of these. Write a polynomial function f of least degree that has rational coefficients, a leading coefficient of 1, and zeros 2 and 1 plus I root 7. So this rest just says write a polynomial. Okay, least degree means the smallest possible degree. You can make it humongous degrees. Just make it the smallest you can, and that's going to just come out in the wash if you just do the least amount of work. And rational coefficients. That means you don't want roots irrational, like root 3, root 2, something like that as a coefficient. You want just fractions or whole numbers or integer, you know, as your coefficients. And your leading coefficient is going to be 1, and that once again will also come out in the wash. So really, what you need to think about is you're going to have a 0 of 2. Well, what gives me a 0 of 2? Well, x minus 2 does. Because if I set it equal to 0, remember, if I set this equal to 0, I get x equals 2. Okay, so that's why we get that binomial there. We also know that we have 1 plus I root 7. Well, I can find that. I could set x minus. So you can always start out with x minus. That's how I can set up my zeros on all of them. So notice I got rid of that 2. Well, I can have x minus here, and I can go, well, 1 plus, I know if 1 plus I root 7 is a solution, then 1 minus I root 7 has to be a solution. That's what the complex conjugates theorem says, which means that this, I'd have to have another set, another quantity. So this is saying x minus 2. This is saying x minus, and I have to put parentheses because I have two terms, I root 7, and x minus I root, or excuse me, 1 minus I root 7. And we set all that f up to f of x. Now the tougher thing is we're multiplying these. So we need to simplify it, meaning we need to multiply this quantity by this quantity by this quantity. And so the first thing I'm going to do is I'm going to get rid of, like I'm going to simplify in parentheses here. I'm going to move this negative in to get rid of these extra sets of parentheses that I have. And technically I have another bracket or parenthesis around each of these. Okay, to close that one. That one is there. Okay, so when I distribute that, I get x minus 1 minus I root 7 times, and I'm going to distribute that. So I get x minus 1 plus I root 7. All right, so I have those quantities, and I still have my x minus 2. And now I can multiply this trinomial by this trinomial. How am I going to do that? I got to say, the easiest way to do it, to keep yourself organized, for those of you who struggle with just doing FOIL, or not FOIL, I guess the distributive property, this times this times that, that times that, and then so on. A nice way is just to make an area model, where you list each term x, negative 1, and negative I root 7. Okay, and you just give each of them their own areas here. And then down the other side, you list your other x, negative 1, and positive I root 7. Okay, maybe my line's a little long and I'm going to be strapped for space, so I'm going to go ahead and do that. And so now I can just go ahead and multiply x times x, x squared. X times negative 1, negative x. X times negative I root 7 is negative I x root 7. Negative 1 times x, negative x. Negative 1 times negative 1, positive 1. Negative 1 times negative I root 7 is positive I root 7. I root 7 times x is I times x root 7. I root 7 times negative 1 is negative I root 7. And I root 7 times negative I root 7, well, that positive times negative is negative. I times I is I squared. Root 7 times root 7 is root 49. Now this last piece that we have here can be a lot of simplification. So this negative is obviously negative, but I squared is actually negative 1. For I times I, root negative 1 times root negative 1 is negative 1. And root 49 is 7. So really, this whole thing becomes negative 1 times negative 1 times 7 is 7. All this stuff equals that. So let's simplify it now. These things right here, these two trinomials multiplied together, give you x squared. I'm going to check off that I've used it. Negative x and negative x is negative 2x. Ix root 7 and negative ix root 7, that actually is 0. Those cancel. We have 1, okay. we have I root 7, or negative I root 7 and positive I root 7. Those two cancel. And from down here, I have 7. Oops, well, I just want to check that off. So another plus 7. So that whole thing is actually x squared minus 2x plus 1 and 7 is 8. That 1 and that 7 go together. And all that times x minus 2. So you now simplified it a little more. I'm going to distribute here. I'm just going to go x times x squared to multiply this out. That's x cubed. X times negative 2x is negative 2x squared. X times 8 is 8x. Negative 2 times x squared, negative 2x squared. Negative 2 times negative 2x is positive 4x. And negative 2 times 8 is negative 16. So all of that is going to equal x cubed minus 4x squared minus 16. X cubed minus 4. Oh, I missed a term there. Sorry about that. Forgot my plus 12x there. That is what f of x equals. And I can't, for some reason, get the f of x in there. So I'm going to rewrite it over here. F of x is equal to x cubed minus 4x squared plus 12x minus 16. There we've got it. Okay. Now, with that being said, in my class when I was teaching this, they're like, isn't there a shorter way to multiply these two trinomials? And really there is. There's a much shorter way. You could just start right here. And you could say, well, 1 plus I root 7 is equal to x. So I'll show this work up here if you want to do a shorter way. You can say 1 plus, actually, let me give myself some room here. 1 plus I root 7 is equal to x. I'm all about little shortcuts. So I'm just going to solve, I'm going to set it equal to 0 by moving everything away, or moving everything over to the side of x. So I'm going to subtract 1 over. Okay, so I'm going to have I root 7 is equal to x minus 1. I'm going to pull the I back inside here. So I'm going to have negative 7. So we put the negative back in, get rid of the I. I'm going to square both sides. And then I'm going to add 7 over. So I get 0 is equal to x minus 1 squared plus 7. Now that being said, if I take that, 0 equals x minus 1 squared plus 7. And I multiply the x minus 1 squared out, that's x squared minus 2x plus 1 plus 7. That gives me x squared minus 2x plus 8. And that thing right there is this right here is exactly what we got right there by doing this whole junk. A little faster in my eyes, but hey, this is how the textbook's going to show it. That's how I show it. It shows the complex conjugates. But I'll tell you what, this is a lot faster, and just makes it a little easier for you. All right. Well, let's go ahead and do our last piece here. I know this is a long lesson, but it'll help out here. Descartes' rules of sign here, of signs. This just helps us to determine how many positive, negative, and therefore imaginary zeros there are. So for a polynomial function, the number of changes in signs of the coefficients helps you determine the number of possible positive real zeros or negative real zeros, and therefore imaginary zeros. So the number of positive real zeros is equal to the number of changes in the sign of the coefficient f of x, or is less than that by an even number. Okay. This last statement just means that if I say, and I'll explain what positive real zeros and the changes of signs here mean in a minute, but just so that we're not confused with this less than this by an even number, you have that in both of these statements. That means if I were to say I had 7 real or positive solutions, just taking a number, for example. Okay, if there's 7 possible, if that's the maximum number of possible positive solutions, then less than that by an even number, well, the even number is 2, so if I subtract 2, there could also be 5. If I keep subtracting 2, there could be 3. Subtract 2 there again, there could be 1. So it could be 7, 5, 3, or 1, because I keep subtracting 2. Can't subtract 2 again because then I'm in negative. Okay, if there were 8 possible, well, that means there could be 6, 4, 2, or 0. Okay, that's what this means. Okay, so if there are 3 possible, well, you could have 3, 1, 3 or 1. All right. The number of negative real solutions is equal to the number of sign changes of the coefficients of f of negative x. So this is f of negative x, this is f of x, f of positive x. Positive x gives you positive real, negative x gives you your negative real. Okay, so let's see what this looks like. So here's a polynomial. We're going to determine the possible positive real, negative, positive real zeros, negative real zeros, and imaginary zeros for this function. First thing you need to do, they already tell you f of positive x, right? F of x, f of positive x, is giving you the positive real solutions. So all you're really doing is looking for sign changes of your coefficient. So you have a positive 6, you have a negative 4. Your sign changed from being positive 6 to negative 4. So it went from positive to negative. That's one sign change. Well, you're at negative and you keep it negative. Negative to positive. There's a second sign change. So we went from a negative 63 to a positive 42. Negative to positive. Positive to positive. Positive to negative. There's a third sign change. Okay, so there are 3 positive real zeros, possibly 3 positive real zeros. Okay, now let's look at negative real zeros. That means I have to look at f of negative x. Now remember when we were testing negative 1 way back here on these problems? I'm saying, hey, all you have to do is switch the sign of the odd powers. Now, it goes the same for when you're testing any negative number. So when I test f of negative x, that means 6x to the 5th is actually no longer 6x to the 5th. It's 6 times negative x to the 5th, which means that negative carries out because it's negative times negative times negative times negative times negative, which is negative x to the 5th, which just pulls the negative out. So if your power is odd, the negative just drifts out to the front. Okay. What do we have? Minus 4x to the 4th. So it's going to be 4 times negative x to the 4th. Well, that's negative times negative, which is positive, times negative, which is positive. Positive x to the 4th times negative 4 is still negative 4. Okay, so the sign didn't change because it's an even. Minus 63 times negative x to the 3rd. Negative times negative is positive. Or excuse me, negative times negative is negative. Negative times negative 63 is positive. 63x to the 3rd. So the negative drift out because of an odd power. 42 x squared. Well, that's not x squared. It's negative x squared. Negative times negative is positive times positive. Positive 42 x squared. 147 negative x, so that's going to be negative 147 x minus 98. Now I'm kind of out of room over here. minus 98, that's obviously not going to change. So looking for sign changes, we have negative to negative, didn't change. Negative to positive did change. Positive to positive didn't change. Positive to negative changed. Negative to negative did not change. Okay. So you end up with, that's a negative 98 there. We end up with 2 negative. Well, if this is x to the 5th, there are 5 total, and if you use 3 for positive real and 2 for negative real, that gives you no zero or no imaginaries left, because 3 plus 2 is 5. That's how many zeros you could have. But now remember, you can decrease by an odd number, right? So if we had two negative real zeros, there also could be 0 negative real zeros. So if I had 3 positive real zeros and 0 negative real zeros, remember I got to decrease by an even number, subtract 2. Now I have 3, 0. I have a total of 5. That means I'd have to have 2 imaginary to make that total 5. And remember, I have to do the same thing here. I have to decrease this by an even number. So this would have to become 1. So I could have 1 positive real and 2 negative reals. 1 and 2 is 3. I have to make 5. That means there had to be 2 there. Or I could have 1 positive real and 0 negative real. 1 plus 0 is 1. That means that would have to be 4 to make that 5. And that's it. I can't go any less than 0. So I'm done. But really, when I say I could have 2 negative real, that means I could also have 0 negative real. When I say I have 3 negative or positive real, I could also have 1 positive real. My total has to be 5. Okay, so I have to pair the 3 with the 2, the 3 with the 0, the 1 with the 2, and the 1 with the 0. And that's what I did. 3 with 2, 3 with 0, 1 with 2, 1 with 0. And I filled in the imaginaries based on making our total of 5. That's what the, using the rule of Descartes, the rule of signs there helps us out with. All right, I think that's all I got for you. Well, good luck.